So guys, now let us try to understand that what is the significance and use of base pointer register. We very well understand the use of EIP and ESP register, but what actually is EBP register? Why it is there and what is the use of this register? So from the previous example, we have the stack frame of function f2 shown here. Right? So it means that the function f2 is currently executing, and in the stack memory, the following stack frame of the function f2 is already pushed into the stack memory. So you can see that by definition, the value of base pointer register is 60, because here at address 60, the base pointer register value of the caller function is saved. And of course, the value of stack pointer register is always points to the bottom of the stack memory. So when the frame is in execution, EBP register value is used as a reference by the function to access all local variables and local arguments of the frame, right? So when the function executes, it has to access its local variables as well as the arguments which is passed to the function by the caller. So as I have mentioned here, base pointer register value is used as a reference to access all local variables and local arguments of the current frame which is in execution. So let us try to understand this with the help of an example. You can see here that the base pointer register value is 60. So EBP plus 0, that is the content of EBP register, is actually the address where caller's base pointer register value is saved. So accessing the value which is stored at address stored in EBP register will give you 84, right? Which is the address where caller's base pointer register value is saved. Now if you add 4 to this EBP register value, you will get the address where caller's next instruction address is stored. So 60 plus 4 will give you 64. It means that by adding 4 to the register value of EBP, you will get the address of the instruction from which the caller needs to resume its execution when callee returns. Now if you add 8 to this base pointer register value, you will get the address where argument 1 is saved in the stack memory. That is 60 plus 8 will give you 68, and 68 is the address where argument 1 of function f2 is stored in the stack memory. Similarly, you can get the address where argument 2 is saved in the stack memory. Similarly, if you subtract from base pointer register value, you will get the address of local variables of the current function. So here you will get the address of local variable var2, because 60 minus 4 will give you 56. So 56 is the address of local variable var2. Similarly, if you subtract 8, you will get the address where local variable var1 is stored in the stack memory. So you can see that CPU accesses all of the data of current stack frame in execution through EBP register value. Thus, for a frame to execute its instructions, EBP value must be set correctly. EBP by definition is the address where caller's base pointer address is saved in the callee's stack frame. And remember, the base pointer is also called as frame pointer. So when callee returns, caller must restore the value of EBP register to point to location where caller's base pointer address is stored in callee's stack frame. So we will going to understand this point when we will going to have a detailed discussion on understanding the mechanism how callee function returns.